Hello. Today I'm going to talk about flight planning for flight simulators, which, come to think of it, is a pretty odd thing to do. I mean, we're talking about simulated flying. Why not just start at your departure point, fly a straight course to your destination, and land? Good question. Well, everyone's got their own reason for wanting to learn about flight planning. From the person learning to fly a real aircraft that wants to practice with a flight simulator, to the person that wants to simulate a real-world flight. So whatever your reason, here's my very simple guide to flight planning for flight simulators. Firstly, how you plan your route depends on whether you're flying under visual flight rules or instrument flight rules. I'm going to cover flight planning for instrument flight rules. This type of planning applies to all airliner routes and any flight in poor weather conditions. Given our weather in the UK, that's probably about 90% of the time. For route planning purposes, it may help to think of our flight as having three phases: departure, en route, and arrival. Each of these phases are approached in different ways, with the departure and arrival phases dependent upon the en route phase. So let's start with that. En route flight planning consists of a series of waypoints and airways between those waypoints. A waypoint can be something like an intersection or a navigation aid like a VOR or an NDB. Intersections are named using 5 letters. Navigation aids are named using 2 or 3 letters. Airways have no standardized naming convention. In general, though, they consist of 1 or 2 letters followed by 1 to 3 numbers. Let's take a look at an example. Here we can see the waypoint STN. That's the VOR for Stornoway, a navigation aid. We can also see another waypoint, INS. Again, 3 letters, so it's a nav aid, and this one is the Inverness VOR. Between these 2 waypoints is the airway Yankee 906. And along this airway are the waypoints ULLAP and GARVA. An airway can have multiple waypoints along its route. Coming north out of Inverness, you can see airway N560 that doglegs to the right at an intersection called Bonby, B-O-N-B-Y. Airways don't have to run in straight lines from beginning to end. An airway then is like a motorway in the sky. It runs between a start and end waypoint, possibly passing through other waypoints. In considering airways, we need to know that airways operate at 2 distinct levels. In Europe, upper air routes start at flight level 195 and are named in the same way as lower airways, but are preceded with the letter U. Let's have a quick look at an example. Note that we're at the same scale, but the lines and identifiers are drawn more thickly. The Stornoway waypoint is used extensively for upper air routes, whereas Inverness is not used at all. In the USA, upper air routes start at flight level 180. Airway names consist of a single letter, either J or Q, followed by some numbers. Lower routes, often referred to as Victor Airways, begin with the letter V or the letter T, followed by 1 to 3 numbers. Let's look at an example. Here we can see a Victor Airway V278 running between the GWO waypoint and the GTR waypoint, both of which are VORs. Here's another section of the American Airways map, this time showing the area around the Florida Panhandle, as well as the Victor routes. You can also see some of the T routes. If we look at the upper airway routes, you can see that we now have airway names preceded with the letter J or the letter Q. Airways that begin with the letter J or V for the lower routes run between VOR stations. Those beginning with the letter Q or T are for RNAV routes. To plan a route, you need a chart showing your departure and destination airports, as well as all waypoints and airways in between. This chart could quickly become very large and very busy. Let's take a look at an example route between Gatwick and Manchester. You can see how enormously cluttered this is, and this is just a short distance of 164 nautical miles. You can imagine if we were flying from somewhere like London to Gibraltar, or perhaps even over the Atlantic, this could quickly become overwhelming and make it all but impossible to try to plan a route. Luckily, there are computer applications to help us, both free and payware. I'm going to concentrate on some free options here. First, let's try RFinder. I'll enter the departure ICAO code. For Gatwick, that's EGKK. For the destination, I'll enter the ICAO code for Manchester, that's EGCC. With those done, I'm going to look at an altitude between flight level 195, of course, which is the upper air route in the UK, and flight level 240. With those done, find route. Ignore the details for the routes down here and just look at the summary up above. Ignore the departure and destination airports and the SID and the star. So now our route is going from BIG to TNT. And if we look at that, we'll find that we're using exactly the same airway from BIG all the way to TNT. And that's the airway T420. In fact, if we wanted to, we could simply write our route as BIG T420 TNT. That's the starting waypoint of BIG, the airway T420, and the ending waypoint of TNT. That's the route. What Route Finder has done for us then is to examine the waypoints and airways and build a route, which is great. But there's one possible problem, depending on how realistic you want your flight planning to be. It's not a real-world route. This is because the only authorized route from Gatwick using the BIG VOR is based on your destination being either Northolt or Heathrow, neither of which applies to us. Which leads me to another free browser flight planner, the snappily named Real World Flight Plan Database, or EDIGLAR as it's usually referred to. I'll enter my departure and destination airports as I did before, so that's EGKK for Gatwick and Echo Golf Charlie Charlie for Manchester. I'll click the search button. I'm now presented with a whole number of real-world flight plans. Let's say I'm looking for a route flown by an A319. The first one on the route is for call sign SHT2906. Bit of an unfortunate call sign, but let's choose it anyway. I now get a summary of the route flown. Ignore the first part that starts N042. That just refers to the speed and flight level. You can also ignore the tail part that starts /0034. That's just the duration of the journey. What we're left with then is this part here. So we're going from the waypoint LAM, which is a VOR, using airway N57 to the waypoint WELIN. 5 letters there indicating that that's an intersection. We then go on to airway T420 to our final waypoint, only 3 digits, it's a VOR called TNT. And that's it. That's our route. If I return to SkyVector, I can see what this route looks like on the map by entering just the waypoints into the flight plan box. So let's copy those details over to SkyVector, click the flight plan box and enter the details in. We only need the waypoints here, so I'm going to remove the airways. And now the route is drawn on the map. I zoom out a bit. Whether you want a calculated route or a real-world route is entirely up to you, but in simple terms, that's how to find your route. Now we have our route, we can choose our SID. The departure phase of our route takes us from the airport to the airways. Most airports have published procedures for these departures, and they're called SIDs. That's Standard Instrument Departure. They're used to cut down the workload of controllers and to help aircraft to safely move from airport to airway. Before deciding which SID to use, we should know which runway we'll be using and which waypoints we need to reach to enter the airways. In our example, we need to get to the LAM waypoint. The choice of runway will depend on the wind. There are many ways to get the current wind, but I'll use SkyVector. And looking on the weather station report here, I can see that the wind is 270 at 15 knots. Next, I need to see which runways are available. Using SkyVector, I can click on Airports and then enter the ICAO code for the airport that I need. So e.g. KK for Gatwick. I see that there are 2 runways, 0826 left and right. Given the wind direction, that means we'll be using runway 26. My understanding is that the shorter runway, that's 08 left or 26 right, is rarely used because there is insufficient distance between the 2 runways for 2 aircraft to pass safely. So this means we'll be using runway 26 left. Next, we need to see which SIDs are available to us, and for this I'll use the freely available NATS service. I'll select London Gatwick and look for standard departure charts. There are quite a few, but there's a naming convention we can use to our advantage here. The charts include the name of the waypoint that the departure leads to. We want LAM. If I search for that on the page, I'll find 5 references for them. Of these, 2 are for coding tables that we don't need, so we can discard them. Of the 3 left, 1 is for runway 08 right only, so we can discard that. Of the remaining 2, 1 is a normal procedure and the other is an RNAV procedure. We'll choose the normal procedure. On checking the SID, there are a few things worth noting. This SID's actually for 4 published procedures. That's LAM4M, LAM4V, LAM5P and LAM5W. The first 2 are for runway 26, and so they potentially then apply to us. Of these 2, LAM4V is for runway 26 right. We're on runway 26 left, so that means we'll use LAM4M. We'll probably need to know this for programming flight computers. Note also that according to the instructions that we need to be at a height of 703 feet or an altitude of 703 feet before we commence any turns. Also, this SID consists of a stepped climb. We need to be under 4,000 feet by det D29. We need to be at 5,000 feet by Acorn and at 6,000 feet by LAM D10. The pilot needs all of this information either to fly by hand or, more likely, to check that the flight computer is correctly programmed with these constraints. And that's it. We've selected the correct SID. So now we're looking at the final part of our route, the arrival. Staying with our example of a flight from Gatwick to Manchester, let's look at the NATS index for Manchester Airport, Echo Golf Charlie Charlie. There are 6 stars listed, but none of them refer to the last waypoint on our route, TNT. However, 2 are for traffic from the north and 2 for traffic from the east. Neither of these apply to us as we're coming from the south. Of the remaining 2, MIRSI or Mercy doesn't mention our waypoint, but Dane does. This is the star we need. On checking the star, there are a few things worth noting. Firstly, we'll be using Dane 2A, and this is because we're arriving via Airway T420. We need to be at flight level 200 by Elvos. We need to be prepared to be at flight level 70 at Dane. We must not proceed beyond Dane without clearance from ATC. The transition altitude is 5,000 feet, and this is the height at which we switch from standard pressure to QNH. Most of this information is going to be needed for the flight computer. But that's it. We've now selected the star. The final part then is getting on the ground. For this, we need to know which runway we're using so we can choose the appropriate approach plate. Back in Sky Vector, let's look at the weather for Manchester. I can see that the winds here are 280 degrees at 20 knots. Let's look at the airport info for Manchester. And again, I can see 2 runways. We have 05 right, 23 left, and 05 left and 23 right. It's odds on we're going to be using runway 23, given our wind direction. Back to NATS and load the page for Manchester, Echo Golf Charlie Charlie. We'll look for an ILS approach. ILS actually is only available on runway 23 right, so that's the runway that we'll use. We have 2 options available to us: approach via MCT, that's the VOR at Manchester Airport, or the ILS at INN. There's almost nothing to choose between them, so we'll use INN. Things worth noting here are the max speed in the approach is 185 knots indicated airspeed. We should start our approach at the initial approach fix, which is overhead the MCT VOR at 3,500 feet. We fly out from the initial approach fix on the 053 radial for 12 miles before turning left to 008. We then turn right to 233 degrees to intercept the localizer. And that's it. All of the tools that I've used here for flight planning are available free of charge. There are payware options available that will make flight planning much easier, but of course there is a cost attached. If you want to see the information we've gathered above put to appropriate use, my next video flies the route using the Aerosoft Airbus A319. That concludes my simple guide to flight planning with SIDS and stars. Finally, if you have any feedback, positive or otherwise, please do leave me a comment below. Thanks for watching.